Hi everyone. In this particular video, I'm going to talk about what is limit. So before understanding what is limit, we need to understand why we need limit. Let's suppose we have a function. So we have f of x equal to x square minus 1 divided by x minus 1. So in this case, if I will say that what will be the output of this function at point x equal to 1. So this will be your number line. Just to make thing clear, I'm just plotting here. So this is point this is a point 1, this is a point 5, and let's suppose there's a 1.5. Okay, and now I'm saying that what will be the output of this function at this point. Okay, so if you try to solve this problem at x equal to 1, you are getting this answer. It is 0 by 0. We really don't know what is this actually. Okay, so this kind of things basically known as a indeterminate format. Okay, so here what is happening? So at point x equal to 1, we are not able to get the answer actually. Okay, we are not understanding what is 0 by 0. Okay, it's a kind of indeterminate format. So how to solve this problem? Okay, think. So to solve this kind of problem, people introduce the concept of limit. Okay, so now it's time to learn how limit work internally. Okay, so I'm not going so mathematically. I'm just trying to explain you the intuition behind the limit actually. Hope now you understood like why we really need the concept of limit. Okay, so if there is any function and if we have a point, okay, and at that particular point if you're not able to find out the answer, okay, that means we are encountering 1 by 0 or 0 by 0 kind of stuff. So we can solve those kind of problem using the concept of limit. And how we can solve it? So to solve it, it's very easy. Okay, uh, instead of taking exact value of 1, if we can go if we can get closer to closer. So in that case, what is going to happen? Like if instead of taking exactly 1, if we take very closest value to 1. Okay, okay, what do you mean by closest value to 1? If I will, let's suppose I will start from here. Okay, and I will go till 1 but not exactly 1, and from here also I will go till 1 but not 1. So first I will test 0.5. I will put 0.5 in this equation and I will note down my answer, and then I will move to the 0.6, and I will go till 0.99999. Okay, so 0.99, that means it is very closest value to 1. Similarly, so on this one I will get some answer. Let's suppose I'm getting answer 4.9. Let's suppose. Okay, I'm just assuming. And similarly, I'm starting from here. Okay, so I'm starting from 1.5. I note down my answer, and then I'm just going closer to the 1. So very closest value to the 1 will be 0.0.0.1. And at this point also, let's suppose I'm getting 4.999. So what we can say here, if I'm approaching to 1, so if I'm approaching to 1, so if I'm saying approaching, that means what? It can be from left hand side or it can be from right hand side also. Okay, if I'm approaching to 1, this function will give answer close to the 4.999. Okay, so this is a basically this is a like idea behind the limit. So what we're doing, so we're testing it from both side. Okay, so we are checking the behavior of the function. Okay, so if we are not able to find out that if you're not able to find out uh, if you're not able to solve the function at that particular point x equal to 1, so instead of taking exactly 1, what we're trying to do, we are testing the behavior of the function, and we are going very closer and closer to that point actually. So instead of taking directly 1, we are going closest to this point 1. So let me explain you with the example here. See, so this is we are approaching from left hand side. So we are starting from 0.5, and we are just noting down all the answer. So here we can see we end with the 1.99. So from this example we can say that x gets close to 1, then if that means what, if the value of x going very close to 1, the output of this function will be 2 actually. So what was happening earlier? At point x equal to 1, we are not able to solve the problem. That means what? We are encountering 0 by 0 problems. Okay, now we are able to solve the problem. So now actually what is happening? So if this is a path, okay, so at this point x equal to 1, and you are approaching from this side, and you say that if x will approach to 1, this function will generate value as a 2. But it is true or false for if you are approaching from this side, that also we need to check. Okay, so from both side, it should produce the result 2. If it's not producing 2, that means what? There is a problem. That means what? We cannot solve the problem. Okay, again, limit cannot solve the problem, that kind of problem. Okay, okay, so let me just explain the point. So when x equal to 1, we don't know the answer. Okay, that is a indeterminate format. But if it is going very close to 1, what is happening? We are able to get the answer. uh, so hopefully you got my point. Okay, so this is the idea behind the limit actually. So how to represent this thing into mathematical one? So it's very simple. So we are saying that we are finding the limit of this function, and this the value of ax, it's approaching to 1. This is not equivalent to 1. So the output of this function will be 2. We proved it. Okay, so actually what we are saying here, ignoring what happened when we get there, but as we get closer and closer, the answer get closer and closer to 2. Okay, so exactly at that point what is happening, we are not caring about those things. Okay, we are just caring about only one point, like if you're going closer and closer to the that particular point, what will be the our answer. Okay, so I hope you are getting my point. Okay, but we need to check it from both sides, not only one side. Okay, for an example, so what will be the, like here in this example. Okay, so just a minute, let me use. So at this point, we are trying to find out the, let's suppose this is x equal to 1. So we are approaching from this side, and we are approaching from the this side. So on the both side, the value should be same. If it is different, again we can say we cannot solve this problem. Okay, so I hope you got. So if I'm approaching from this side, we call it left hand side limit, and if you're approaching from this side, this is called right hand limit. So basically we represent like this: limit x approach 1 minus. So this is not a minus 1. Okay, this indicate that we are finding the limit of that particular function from left hand side. That means what? We are trying to find out the value uh, of a function, like we are going closer to 0.1 from left hand side. Okay, so this is basically known as the left hand limit. If I'm writing like this, x1 plus, that means what? We are trying to find out the right hand limit. Okay, so this should be same. Okay, the value should be same. Okay, so now see what we can say. So we are testing it from like here. So this is 1, this is 0.5, and this is a 1.5. So we test it from this side. Now we will test it from this side. Now you can see the answer will be very same. See, we are trying to find out, we are trying to test it for different point. Now the closest point to 1 will be 1.0001, and answer is 2. So we can say like, okay, so this is also we are ending with 2. That means what? Left hand limit and right hand limit are equivalent. That means what? If x is approaching to 1, that particular function is generating output 2. Okay, hope now you got my point. We'll also implement this thing into Python 1. Just wait for a minute. I just want to explain some few points. Okay, so like let's say some more cases. Sometime limit doesn't exist. Okay, for an example here in this case. Okay, uh, so this is you are let's suppose you are trying to find out the you're trying to find out the let's suppose there is a one function. Okay, and now I'm saying that what will be the value of this function at particular point a. Okay, and now so to find out, you are applying the concept of limit, and now you try to find out the what will be the left hand side limit. Okay, so now from the left hand side you encounter 3.8. Okay, and from the right you got 1.3. So the left hand limit and right hand limit is not equivalent. So in that case we can say that uh, limit does not exist at particular point A. Okay. Okay, so now you got my point. Okay, the left hand limit and right hand limit already I explained. This is very nice article actually. I will share the link into the chat. So limit is not only for the difficult function, we can solve any simple function. So here we can see this is not like if I will put directly 10. Okay, so this is not going to happen anything. Okay, so this is not generating output 0 by 0, so we can directly put it. Okay, we will come to this problem. Okay. Okay, so before going to the infinity, let's implement this concept in the Python, so that we can we can understand the limit concept very well.